Hello, everyone, and welcome to Rational Science, directly from Frankfurt, Germany.
Live.
Live. And today we're going to do a review of the month of March, and I'm going to be doing first a little bit of extinction theory. Okay, then I'm going to do a little review of what we did this month, which was primarily geometry, geometric figures, and I'm going to do that with questions that people ask because that'll drive the whole conversation. And at the end, I'm going to open the floor for any questions that you may have. So get them ready, get them started. We'll try to answer as many as we can.
What is a circle?
Let me start by saying tomorrow's April Fool's Day. And I celebrate 45 years of marriage. Okay, 45 years with the same woman. And no regrets. And I can only wish for everybody out there to have the same kind of marriage that I had. Had a great marriage. We had great adventures with my wife. And we only made one big mistake in our lives, and that's this guy here. And I told her, abort, abort. And she said, but I want to know what he looks like. Oh, brother. Oh, my. And that's how
I didn't disappoint.
Okay, so let's get started. There was a fellow who asked the question in regards to extinction. I'm just going to cover his question because I think it's important to go through the little steps there. Okay, so let's go with his question. And he says the following. If I can get it up here. What mechanism did you think of for the sudden disappearance of some types of plants that were direct and unique nourishment for some animals? Remember, the theory is that we had collapse of the ecological collapse, essentially, the overturning of the ecological pyramid. And what disappears is primary production. And that's what he's referring to here, okay? Okay, so let me start by clarifying this. Okay, we want to distinguish background extinction from mass extinction. Two different mechanisms, according to this site, okay, to this channel. Okay, mass extinction, many species. Background extinction, one species disappears, okay? What's the general mechanism in the case of a mass extinction? And again, we're talking about animals here, okay? Overturning of the ecological pyramid. And in the background extinction is the overturning of the population pyramid. It's the demographic pyramid that overturns. What causes the first one? The overturning of the population pyramid of plants. Okay, the plants suffer their long-term decline finally, and all animals that forged a relationship with these plants for millions of years, all these families, they go down with the plants.
The ones that ate these plants die, and then the carnivores that ate the
Right.
plant eaters die.
And the other issue there is that they can't switch at the last moment. You know, a rabbit doesn't go from lettuce to bark or to Christmas tree leaves, you know, from morning to night. He can't switch overnight. And in the case of the background extinction, what causes it are extensive inbreeding, the founder's effect, and population bottlenecks. That's in general terms. And there's the example of John Calhoun's mouse utopian universe. He ran many experiments. They all ended in extinction because what happens again is you have a group of animals that are born or expand demographically from very few grandfathers. Okay, so that's essentially it. And let me put this up here now. And that's a little disclaimer for when we talk about the aging of a species. Okay, whether a species is old according to Mother Nature has nothing to do with how many times the Earth went around the sun. Okay, it has to do with something else. And here are the telltale signs that a species is likely old. And you'll note that all of these refer to man. Man is an old species. What are these signs, clues? Numerous individuals, high density. We're, 8 billion people. Large for a given species. We're a large mammal, and among the primates, we are also big. And that's known as today as Cope's Law. That means that animals, start out relatively small, and over time they grow bigger and bigger and bigger. Okay, and that's how the T-Rexes became big, and that's how we became big. They're sedentary. They no longer colonize the land. We can no longer colonize the land. We have already colonized the land. Okay.
T-Rexes colonize the land?
Yeah, when you reach a certain region and then you don't expand anymore, essentially you become sedentary. You don't migrate anymore for whatever reason. That's the end of you. The redwoods in California, they're sedentary as well. They used to migrate. I mean, they used to cover the planet in different parts, and they no longer migrate. Endemic diseases, they become resistant to it, and that's part of the reason, they're sedentary. They get used to the diseases locally, and they are able to withstand them after a while, after trial and error. Okay? Low reproduction, and also low genetic diversity. Those are, in general terms, the characteristics of a species that is old. And we meet all those conditions, humans. Okay? Not that we're going to die in a background extinction, but if you look at the Neanderthals, they also met all those conditions. Okay, so I'm going to talk, to answer this gentleman's question, I'm going to talk about the Permian, because I think that's a pretty good example of how the animals disappeared because of food. Okay, what changed was their environment, and by their environment I mean their food, not anything else, not the weather, the climate, anything like that. And here you have a little map of Pangaea. This is what the Permian looked like in those days, the end of the Permian, 252 million years ago. And in the south, you'll see that green area that was covered by Glossopteris, a type of seed fern that covered all those regions. And that's how they think that all these pieces of continents, or some are continents today, were pieced together. They were part of the same puzzle, because this plant covered that whole region, and so did some of the animals that lived in those days. They can find them in all these same places. And Pangaea is divided in two parts: Gondwana, which is the southern part of south of the equator, and north you have Laurasia. In Laurasia, you get to Russia. And you get to Perm, the region of Perm. That's where the word Permian comes from. And there you will find also seed ferns. You have Tatarina, Persongia, and Permotheca. And all these are seed ferns. They disappeared together with the Glossopteris in the southern hemisphere. And yeah, it's very coincidental. When these plants disappeared, the animals disappeared. So it's kind of coincidental, wouldn't you think? And did seed ferns die out completely? No, in the Triassic you have the Dicroidiums, which is a different type of seed fern that continued. But it was a seed fern that these animals wouldn't have eaten. Remember, the Triassic was the age of the archosaurs, crocodile-like animals. They governed the Triassic for the most part. And they ate dicrodiums. The herbivores of that age ate dicrodiums. You say, well, a seed fern is a seed fern. Isn't it the same thing? Animals can eat one or the other. Well, that's like me asking you if you can eat weeds. I mean, weeds are angiosperms, and they're flowering plants. But we don't eat weeds. We eat lettuce, maybe tomato, maybe some orange or whatever. But we don't eat we don't eat these weeds, and they're all angiosperms. And that's how you have to look at this. Dicrodiums are not the same thing as these Glossopteris. Okay, they were different types of seed plants, seed ferns, plants. And so they couldn't switch overnight to the dicrodiums. Okay, that's in general terms. These are the animals you'll find in the south area in South Africa, known as the Karoo. And you look at those and say, okay, that looks like a lion, and the other one looks like a hippopotamus, maybe, moss chops and Bradysaurus. And there's a little difference between these animals and what we have today. And let me give you an example here so that you can put it in the right context. Imagine a lion that lays eggs. Okay, does that make sense? You say, oh, what do you mean a lion that lays eggs? Well, these animals, as you see them, they laid eggs. So they're known as mammal-like reptiles. They had more reptilian characteristics than they had mammalian. Okay, and so that's the type of animal that disappeared in the Karoo. Okay, up north in Siberia, you had there's the region. You have the Perm region. You have the Sokolki assemblage zone. That's where they find a lot of these animals and plants. That's heavily studied today. That whole region, and these are the animals that you'll find in there. You'll find Inostrancevia, okay, which is a type of, I guess, tiger, lion, whatever you want to think of that is. And you had Scutosaurus, which was a pariasaur. And the types of plants, as again, you see them there on the right, okay, they were seed ferns. That's what they look like, more or less. That's how we've reconstructed them today. And you'll read on the bottom left there that there were 4 orders of these seed plants, and they're referred to pteridosperms. And I'm not even going to bother pronouncing these things. I don't know why the paleontologists invent all these weird names for them, but essentially these seed ferns were around. They were maybe 90% of the flora out there at the time. In some places there were only some of these plants. And when they disappeared, what do you think the animal's going to eat? He's going to switch overnight and say, well, I think I'm going to eat conifers now, which was the next group of plants to come, into the landscape. Are they going to switch overnight and say, oh, I'm going to start eating cycads now? No, never happened, never will. Okay, they can't switch overnight, not after forging a relationship of millions of years.
I bet they tried on their last days.
I don't think so. It's like,
you get hungry enough, I'll eat bark.
You'll eat.
We'll try it.
A lot of people will say that.
I don't know if I'll digest it, but I'll try it.
That's another one. One thing is that you want to eat to fill your stomach. Some people that were caught in a situation where they were starving, they started eating bark in desperation. And it doesn't help them because it's not food for the body. It's not nutrients. So you can eat it. I mean, you can swallow it and maybe it calms your stomach, but it doesn't do anything for your body because it just goes through. You don't have the bacteria that can digest all that stuff for you. Okay, important to note this was the only insect extinction that happened also in the Permian. And we read, you see there, it says, the End Permian is the largest known mass extinction of insects. According to some sources, it is the only insect mass extinction. And they say insects with piercing and sucking mouthparts began to decline during the mid-Permian. And these extinctions have been linked to what? To a change in flora. Okay, and from the, with the end of the Paleozoic, you enter this region, this age that lasts even until today, where the insects essentially can tell who their grandfathers were. Before that, the insects that belonged before that became extinct and completely. And here, let me give you some examples. This fellow here, he's known as Arthropleura. And he lived in the Carboniferous.
Is that a big centipede?
Yeah, 2.5 meters. You can see the size of that. And there's the fossil. And you look at that monster and you say, Jesus, I don't want to see him in a dark alley, And it turns out he was a herbivore. Okay, this animal was a herbivore.
Dodged the bullet.
Yeah, they figured out by their stomach contents, that kind of stuff, or the plants that were around them for different reasons, or the mouth parts and so on, they decided he was a herbivore. But in the Permian, you get this monster, okay? And this is a little dragonfly.
Little.
2 feet long
wingspan.
And this guy was a carnivore, okay? And maybe he grew that big because he didn't have too many enemies, especially when he got to that size. You probably wanted to avoid him, not to hunt them down.
You don't need a fly swatter, you need a baseball bat.
Holy shit. Yeah, so these were big monsters that you had in those days. All those animals, right, insects, right? They disappeared, and then a new wave of insects that lasts even until today essentially, covered the land. And so all I can show you to answer the question here is the plant evolution. This gives you a snapshot of what I'm talking about. You have different ages, and every age has its plant, and every age, because it has a certain type of plant, it also has a certain type of animal that depends on that plant. Herbivores first and carnivores that live off the fat of the land, off the herbivores. And you have the early part. I'm just going as far back as the Devonian and Carboniferous, and you'll see the non-vascular and early vasculars. You'll have the horsetails. You have certain type of plants that essentially disappeared today. There are other varieties of horsetails today, but nothing to do with the ones that existed in the Carboniferous. From there, we went to the age of ferns, you can call it, specifically the seed ferns, but ferns after all. And those were the Permian and Triassic. Then when you have the Jurassic, which is known as the age of cycads, Jurassic was all cycads. All these other plants vanished completely. And they were in the background, like you have ferns in the background, but they're not the primary part of the landscape, okay, of the flora. And then, when the angiosperms, I showed the graph the other day, the angiosperms displaced the conifers, that's when we came into being, and that's when the dinosaurs disappeared. So I'm saying that when the plants die, that these species, these families of species, forged a long-term relationship with. When the plants go, so do the animals go. And that's why we don't see dinosaurs around today. Okay?
In a way of speaking, it's as if all the food we ate disappeared, but food that other animals eat was still around.
And that's what differentiates why some animals survive. That's the discriminating factor. One food chain goes away because it depends on a certain type of flora.
Yes.
The herbivores on that, and the carnivores on that, on those guys, and all the others are completely unaffected with what happens, to the big guys. Usually, it's the big guys that go away, and the small guys who are radiating with the new vegetation. They don't know what's going on. They say, hey, we don't have the big guys stomping on us anymore. Let's expand.
I think that's an important part that's never taught in schools and stuff. Yeah. They always talk about the circle of life and like the food chain, but they don't talk about food chains with plural. There's plural food chains parallel to each other. One can go down without the other one falling. But usually it's spoken as in the food chain as if everyone is connected.
Yeah, and that's not true, because not everyone is connected. There could be maybe a tiny connection, maybe at the insect level, that maybe is so far removed from us that that's not what supports us. I'll give you an example. In the Cretaceous, what died were the diatoms and the other foraminifera and plankton in general. Those were eaten by the ammonites and the mosasaurs, which were these big monsters, reptiles, not fish, reptiles that lived in the sea. They ate, or they subsisted primarily on ammonites. This was a food chain. And guess what? All three of them disappear. Now that's kind of weird, isn't it? That just the three that disappear.
The asteroid hit exactly those three.
Just hit them right on the nose. Yeah. It's very strange that would happen. Now, you would think that it's got something to do with food, and that's Mother Nature's henchman, food. That's what she uses to kill species massively in a mass extinction. Okay, and so that's the answer to this gentleman's question. Okay, let me get to the review of this month, which was primarily geometry. We covered the...
that's my cue to leave. I don't want to hear about triangles and squares.
No, these are circles, squares. We had the semicircle. We had the triangle. And the bottom line, or the main message, was no one has any idea what those geometries are. Why? Well, now we're going to get into the questions that people ask, and you'll see why and the kind of answers I'm going to give them.
But they're not just devil's advocate questions.
No. Even if they're devil's advocate question, they're fair game. Yeah, they're fair game. I don't have a problem with that. Okay. If the guy wants to, take it to the limit.
Some of those questions, like, what do you need the answer for that?
Yeah. Okay. Let's go to the limit. No problem. Okay. This fellow says, what is the difference between geometry and physics? Okay. Geometry has irrational foundations. Okay. Why? Specifically, the point, the line, and the plane. What's a point? A location. What's a line? An itinerary. What's a plane? A hollow boundary. Okay? So, are any of these geometric figures? Figures. Is this what we understand by a geometric figure? An itinerary? A location? Is that a geometric figure? And so we have a problem because they point to a geometric figure, but the description or the definition has nothing to do with what they're pointing to. That's the main point that I'm trying to get through. So that means that the foundations are irrational.
You're saying specifically a point isn't a dot, it's a location, which is a
Right.
concept. You're saying a line isn't a static, continuous line.
Yeah.
It's an itinerary where you place a whole bunch of dots.
Yeah.
And a plane is a hollow boundary? What is that?
Yeah, it's just a perimeter. But what is the perimeter? It's just an itinerary going around. In other words, in the case
Many
of a
lines.
circle, it's just a orbit and so on. In other words, it's a bunch of locations. Locations of what? Of a point that's going around.
So it's a
What's a point? It's a location. We have a location going from location to location because there's nothing in the location.
So it's a bunch of verbs and counting, but
Yeah.
no shapes, I guess.
So that's my argument. Okay, the foundations of geometry are rotten. Why? Because they try to merge physics with mathematics, and those two cannot be merged. Mathematics is a language, physics is a science. One has nothing to do with the other, and they cannot be merged under any circumstance. Okay, so geometry is the vain attempt to merge mathematics, which is what? Quantitative descriptions, with physics, which is a qualitative explanation, or a bunch of qualitative explanations. Geometry is not a part of science because geometry doesn't explain any phenomena. Okay? Science is explaining, and geometry doesn't explain. Geometry just does a description, and what does it do? It's just an exercise in ratios and relations. You look at angles, you look at lines, how long a line is, that sort of thing. Okay, so there is no explanation coming out of geometry, except when Mr. Einstein tried to say that, gravity is a geometric theory, and we'll get through that, I guess. Physics, on the other hand, is a branch of science, rational explanations of what? Of mechanisms. You have to explain something, and hopefully in physics, what we explain are mechanisms.
The other guy has to end up with a movie in his head, and math doesn't give you any movies.
Yeah, it's just you look at an angle, you look at you calculate, if you have a ratio between two lines or whatever, things of that nature, and all those are descriptions in the best of cases. You have it doesn't explain anything. It doesn't explain gravity, except for Mr. Einstein. It doesn't explain light. It doesn't explain, or how light works, for example, the slit experiment, or, polarization, anything like that. It doesn't explain gravity. It doesn't explain magnetism. What are you going to explain with geometry? Geometry is just you could say a study in calculations related to angles, to sizes of things, ratios, relations, that sort of thing. Just a description. That's all geometry is. Okay, so let's get to the specific issue. This fellow says, if I can get this thing in there, okay. In geometry, a point is a location. He's saying that, okay, and he got this out of somewhere, and I said the same thing the other day, but yeah, that's what everybody understands. It's a location that has what? Zero height, zero width, zero length, zero dimensions. So far, he described nothing. That's, I guess, the definition of nothing. Zero, nothing. That's zero, everything. So concepts such as locations don't have dimensions. I mean, does intelligence have dimensions, length, width, and height? Does energy have dimensions? Does mass have dimensions? Does a field have dimensions? What dimensions? Length, width, height? What dimensions do these concepts have?
X, Y, Z is usually was used for graphs.
And then that which has no dimensions is not a figure. So if a point does not have any, it doesn't have zero, has zero width, zero length, zero dimensions, well, so far you described nothing, and nothing is not a figure. So there you have the point of geometry right underneath the arrow there. That's what it looks like nothing. Okay, so yeah, you can't say that if geometry must start with a figure, you cannot say the point belongs to geometry, because the point is a location. Location cannot be described in terms of dimensions, and that which has no dimensions is nothing. So far we have nothing in front of us, okay? Which is what a black hole is, because a black hole is zero-dimensional from every point of view. Remember, Chandrasekhar proved it mathematically and got a Nobel Prize for it. So you can't go back and say, well, no, that's not what he said. Yeah, Chandrasekhar got a Nobel Prize for putting an equation saying that the star collapses to zero size. And Arthur Eddington got so upset, who was his boss, right? Who was his, guru, objected to that and didn't allow him to print that stuff. He published it somewhere, and both Einstein and Eddington criticized that, and they said, no, a star cannot collapse to zero size. These are their own words. Okay, so yeah, don't tell me that a black hole is zero size. It is not zero size. It is. Okay, it collapsed. There's nothing stopping it from continuing to zero size, because all they're going to talk about is mass, not about the structure. So if it collapses to a point, all you have is a location.
Well,
The center,
geometry.
Yeah, but that's part of geometry. In other words, they're saying that because geometry enters the picture, especially in string theory, where you have, this collapse of a star. It collapses to a point. Point geometry, right? Geometry. What's a point? Location. All we have is a location full of mass, a concept full of another concept. So yeah, that's how this stuff seeps into the language from geometry. Okay. Okay. Here's the line. Okay, a big important line, very important in so-called geometry. What was a line? An itinerary. Okay. A line is defined as what? A line of points. What was a point? Location.
Wait, a line is defined as a line?
Well, line of points, he means, like a bunch of points. That's what he wants to say, like, a sequence of points. That's what he meant by line of point. But yeah, what he's saying is it's a bunch of location, because we just settled that a point is a location. So we have a series of locations. What is that? That's an itinerary. That's not a line. Okay? But they put a line, a geometric line, usually a continuous line, to represent that, when there is no such thing as a line made of a single piece, a continuous line.
They use a lot of representing. I think that's the problem. They represent a lot, which is code for cheating.
And that's the word they use. They say, no, that's a representation of a line. That's a representation of a point. What do you mean a representation? Either it is or it ain't.
Yeah, why bother with representations?
Yeah. And then he says that extends infinitely. Oh man, extends and infinitely. We have two problems there, okay? In two directions. It has one dimension, length. Now, there's no geometry that has one dimension, okay? So if a line is a bunch of locations, points, right? Then the line doesn't extend, okay? Only objects may be said to extend, okay? You're talking about something else, not extension. Extension is when you extend your bubble gum. That's extending, okay? But here we're talking about something else. A series of locations is not a geometric figure, okay? And that's what a line is, according to that definition there, which is what people have out there officially. A series of locations known as an, what? Itinerary. An itinerary does not have dimensions, length, width, or height. Dimensions are the sole province of objects and figures. Only objects and figures or things can have dimensions. You cannot say a concept like intelligence or information has dimensions. It's irrational. Infinity or infinite is an adjective. In physics, it is irrational to use it as an adverb. See, you can't say it's infinitely, like you said there. No, what he meant is something else. A series of points go on forever, incessantly. You have to use an adverb. You can't use an adjective that you force.
What's the difference between infinite and incessant?
Well, the infinite is referring to an object. You can say, assuming, right, that an object is infinite, which is a contradiction because all objects are finite. But you can apply it to the word object because it's an adjective. You can say this object is infinite, meaning that it extends forever.
It's devoid of verb.
Yeah, in other words, it occupies the whole universe and beyond. It's like this object is infinite. You can use it in that sense, and that would be irrational because all objects are finite. But you cannot say, I run infinitely. You can say, I run eternally. You can say, I run incessantly. You can use adverbs for that. You can't use an adjective and turn it into an adverb in these contexts. That's what he meant by extends infinitely. So, the language is important here.
Well, extend is a verb, so I guess if you took it literally, it would be like the bubble gum stretching forever.
Yeah, but even in that case, it doesn't.
It would be incessantly.
It extends incessantly.
Yeah,
you can't say infinitely. Okay.
Is infinitely even a word?
Yeah, it is a word because it's used by mathematicians who talk about the number line, like saying, for example, the real numbers, they extend forever. You can continue counting until you die and beyond. Okay, even when you go to heaven. Okay, here's a line, and what is it? A bunch of locations. So what we have is a turtle at different locations. That's all we have for a line. That's the definition of line we have today, just locations. So what they've done is they turned that into a solid stick, okay, which is not true. It should not be like that.
You mean a series of locations that something goes through, I guess you could say?
Yeah, in other words, the line of geometry is just a bunch of locations. And all you're saying is that we have a turtle there and it's got different locations. And that turtle, if you were to put it in each frame of the Universal movie, that turtle would occupy one frame for every
Location.
split second. Yeah, for every location it's got.
Between each split second,
There's another location. So all you have is more frames. And every frame
Why
we should...
make it so complicated? What fringe examples do they need to go to such lengths for?
Because they wanted to incorporate physics with math. In other words, that's what geometry is, an attempt to merge the physical part, which is what you can see, the figure, with what they're going to do, which is, we want to look at ratios and relations. Mm-hmm. And so they said, well, this has to do with math because we're going to be doing angles and calculating sines and cosines. And this has to do with physics, which is the object itself. Mm-hmm. And today, that's why we don't have any objects in so-called physics, in other words, mathematical physics.
They extracted all the ratios and then they just left the objects.
Yeah, and they don't pay attention to the objects because a mathematician doesn't deal with objects. And that's how we ended up with this, which is the circle. Let me put it over here, cover your face. Okay, why? Because what are you staring at? Well, you're staring at an orbit. And what's orbiting? A location.
What?
Yeah, a location.
A location is orbiting?
Yeah, the location is orbiting. Location is at different locations. Because the dot is not there. The dot is there to represent the location. What is a location? It's just the location occupied by a location because there's nothing in that location. Okay.
I'll take a shot every time someone hears location.
Yeah, and so here you have the square. Okay, that's what a square looks like. It's an itinerary.
We're just talking about a location following location.
Yeah, that's what it is. That's all it is. And here we have the triangle. We cover that. Okay, there's the triangle. Okay, so all we have is a bunch of locations. That's known as geometry. Those are figures that you stared at. That's what they're saying. So we have a rotten foundation for geometry. And you're saying, well, who cares? Because what we're interested is in the ratios, in the relations, all that stuff. Yeah, but see, we have a problem because then they extrapolate that to physics, and they start telling you that gravity is a geometric phenomenon. That's where the problem is. That's where the danger is. Okay, because they say, it's geometry.
What do you mean?
I mean, where do they get? What is a string? And they say, well, it's a line. See, it's not a string; it's a line. Okay, let's get this straight. They use the word string. You say, okay, I know what a string is.
String theory?
String theory. Here you have, that's a string, right? We all understand what a string is. Okay, you see it there? And they say it's a string, and we say, okay, I understand what a string is. In fact, a lot of people think that these people are talking about strings. They're not talking about strings. They're talking about line because they're doing all this mathematically. That you're not supposed to. The string is there to represent what the line.
Word again. Represent.
Yeah, it's to represent the line. What is the string? It's a bunch of locations. It's an itinerary, and what they're doing is they're vibrating the itineraries, and that's the particle. The particle is a vibration of an itinerary, and until you understand it, you don't understand string theory. String theory has nothing to do with objects, with strings. String theory is a geometric theory. Okay, so geometric theory that tries to explain gravity, that's trying to unify general relativity with quantum mechanics. What is quantum mechanics? They use the dot. What is the dot? It's a location. The dot is the representation of a location. They call it a particle, but you're talking about what? An equation. And they're trying to unify that. They're trying to quantize space-time, meaning they're going to take space-time, they're going to chop it up into little dots, quantum dots. And with that, they're going to try to explain how a black hole works, because what they're interested in, that's where they think they can merge the two. The black hole has the singularity that they get from quantum mechanics, and it has the space-time curvature that they get from space-time, from general relativity. And so they're trying to play around with that mathematically, and they say, okay, we came up with strings. What do you mean by strings? What's an itinerary? It's an itinerary. What do you mean an itinerary? It's full of locations. And what they're going to look at is these relations between the itineraries and what happens inside a black hole. That's what they're doing, because they think that's where the what is it, the golden, no, what was it, the I can't, there's a term for the golden, not the golden fleece. I'm thinking it's their goal. Their goal is, to merge these things, and to merge quantum mechanics with general relativity. And the way they do it, through geometry, because they say geometry works, gravity works in space-time, works in general relativity. And here we have the point, which becomes a line. That's geometry too. Hey, all we got to do is put them together. Okay, that's the issue. That's where the danger is with geometry. They're introducing it into their physical interpretations and misleading you again, because they're not talking about objects at all. There are no objects in mathematical physics, not one. All the objects of mathematical physics are what? Particles, which are equations; black holes, which are singularities, mathematical singularities; space-time, which is what? What is time? Is that a physical object? No, that's a number, and so on and so forth. It's all equations. It's all mathematical, what they call objects. No, it's not a mathematical object, because object is something else. But they turned it into a mathematical object so that they could give you a physical interpretation. And what do they use? They use words such as, well, that's a field, and that's energy, and that's mass. And you think they're talking about objects. No, they're talking about mathematical concepts, quantities, which is what they can put in their equations.
Was Holy Grail the word?
That was the word, the Holy Grail. Yeah, that's the Holy Grail of string theory, to try to merge, quantum with general relativity. Okay, here we have another question. And says, the word science does not mean and will never mean rational explanation. Science, the episteme or epistemological, I guess, is knowledge. The so-called man of science is simply the man who knows.
Where did this come from?
Yeah, this is a fellow who put this comment there. And the answer is no. Okay, first of all, the word knowledge has never been defined. To this day, we don't have a definition for the word knowledge. So you can't use an undefined word to define science. Even though the word science comes from scire, which is the Latin for knowledge, that's when the Greeks and the Romans screwed up, because science has nothing at all to do with knowledge. And that's why we have to define these terms to find out what they meant and what it means today. Today, we don't have a definition for the word knowledge. Everyone uses Plato's justified true belief. That's the definition of the word knowledge today. And knowledge is equal to belief, essentially. Knowledge, when you know, means that you have a belief. Because the other guy on the other side of the planet, his knowledge is a little different. His belief is a little different. So when you say that you know for a fact, that's your religion.
We had a really long talk with this with some friends. And my brother kind of had a really good example talking about flat Earth theory. How back in the day, in medieval times, they thought the world was flat and the Earth was the center of the universe. He said back then they knew the world was flat, and now we know it's not. So what does "no" mean? A lot of people know that God exists. You can't even talk about him. That one's trickier, but I'm just saying the flat Earth one is a good example, because that one is basically by democracy. How many people raise their hand up for this belief? That's the no.
Yeah, and you can do that today. You have the flat earthers today, and they don't believe the earth is round. And you say, hey, I know the earth is spherical. I know the earth is round. And they'll say that I know differently. So who knows?
Yeah, but when we kept saying, what's wrong with using the word belief? And they're like, but that just sounds so wishy-washy.
So
they didn't like that word. That's not a good word for like science and technology.
This is the danger.
I believe if you walk up as the architect of a building, you say, I believe this won't fall. That's less ensuring.
I know this won't fall.
I believe it'll fall. What do you mean you believe? You better know, motherfucker.
What do you mean you believe?
Yeah, it's like a different weight to it, knowing.
Yeah. And so here, let's complete that. Here we have it. Okay. So we have to define these terms. Knowledge, what is knowledge? This is according to my definition, okay? Knowledge, predicting the result of an experiment without error. Okay, that's what knowledge means.
Wait,
Has always meant.
But that's in retrospect.
Yeah. What we're saying here is that if you want to show your knowledge to someone, how do you show it? How do you show to the professors at the university that you know? Are you just going to say, well, I know that Napoleon went to Waterloo? Well, how do you know? I mean, did you just read a book and memorize? Were you there? How do you know that Napoleon went to Waterloo? So you cannot talk about knowledge in past tense, in consummated events. You can talk about explanations, you can talk about descriptions, you cannot talk about knowing that Jesus Christ was hanged, that Caesar went to England. You cannot talk about knowledge in that sense.
You mean you're repurposing the word so that you can only use it for something you can predict?
Yeah, and the only purpose of the word knowledge and the only way you can use it consistently is saying, look, I can predict what's going to happen. For example, if I let go of a pen. I let go of the pen, it falls to the floor. I know it will fall to the floor. And by that you mean that you can predict exactly that. Every time you let go of the pen, it falls to the floor. It turns out that you're even wrong there because you say, okay, I'll bet you $1 million this is going to fall to the floor. And it turns out a comet hits the earth and neither one of you collects your bet. Because the pen never made it to the floor. The comet destroyed. You didn't know the comet was going to hit the earth, for example. So you cannot
believe. You didn't believe the comet
was
going to hit
the earth. Or it turns out that you have a horse, right? And it turns out that you say, I know that horse is going to win the race. And that's because you maybe bribed all the other jockeys or you put some device that hurts the other horses or whatever, and you say, okay, I'll bet you $1 million your horse doesn't win. Your horse number 5 won't win. And the guy says, okay, I'll bet you. And the horse is about to reach the finish line. I pull out my gun and shoot it. It never makes the finish line. And the others just walk right through. Even the turtles pass them. So you didn't know that the horse was going to win.
So the way you use the word no, you can't. It would be incorrect in the sentence, I know the pen is red.
Right.
Because you can't predict the redness of the pen.
Well,
so it would be a misuse of the word.
Again, in that, right, it's a misuse of the word because that's a description. We're talking about predicting something that's going to happen in the future. Okay, so that's what I'm saying knowledge means. And that word there has nothing to do with science at all. Science deals exclusively with the past, with consummated events. There's the definition. Deals with theories, explanations, the causes underlying a mechanism, physics, or reasons that led to an event, philosophy, or the prosecutor's version of how or why an event happened. Happened, past tense, ed, okay? Description, what we don't do in science, is a listing of properties or behaviors of an object.
Well, you do that too.
Yeah, but but that's not the core of science. Yeah. And people mistake the core of science and they say, well, we have to describe it. And I'll get to that in a minute here, in fact. So I'm getting ahead of myself here. Let me get that out. Okay, let's get to the next issue here. One person talks about wrong and right. What's wrong? What's right?
Yeah, it doesn't have to do with facts.
Well, we'll get to that.
One of the comments talking about the difference between the Earth being flat being a belief or a fact.
Yeah, okay, we'll get to that. Okay, it said that whoever, this is the comment the person made, said that whoever has a degree in science wrongly defined is a scientist, or whoever is employed in a scientific laboratory wrongly defined is a scientist, or who simply deals with scientific topics wrongly defined is a scientist. All wrong. Okay, first thing, wrong is an opinion. Right, wrong, that's your opinion. Okay, so whenever you use the words right, wrong, correct, incorrect, true, false, all those are opinions. That doesn't enter science. That's totally religion. Opinion, belief, religion. And then the second part of that is that this argument merely corroborates that the word science has never been defined rationally. Because if those are the definitions people have out there, then we don't have a definition for science, if that's what people think that a scientist is, okay? Okay, so let's get on to another common question here. Give me a second. Pulled it from the bottom here. Fella says, tries to define, says, science is well defined. Yeah? No kidding. And all the dictionaries in the world say more or less the same thing. Okay. Change the meaning of a word that humans have been using for a few millennia. It is impossible. You have to use or invent something else.
That's kind of what I keep saying too.
And I'm saying no. We have to fix what is broken. science is defined irrationally. We don't have a rational definition of the word science, and we have no scientists on planet Earth because they're all following this religion, which people call science. Oh, I thought for a moment it was cut off. Democracy voting, you know what this guy's referring to, has nothing to do with science. They're not scientific criteria. You can't say, well, we're going to vote.
We're going to vote on what the facts are?
Yeah, no, on what the word science means. We don't vote in science. In science, you have to fight for your definition. You have to get into the ring with your sword, your shield, right?
What does that mean exactly?
Well, you have to fight. You have to defend your definition. And if someone shows in a rational way, you know, in a logical way that your definition has a contradiction, I'm sorry, you can say, well, I still believe in it. Yeah, you can believe in it, but you're not in science. Now you're in religion.
Because there's a contradiction in what you're saying.
Right, the guy shows you that you have a patent, the obvious definition, contradiction in your definition. And then again, you can't use tradition and authority, which is what this guy is saying. He says you're trying to change the meaning of the word that humans have been using for centuries.
This is how we've always used it.
Yeah, that's not an excuse. That's not an argument.
Well, because we're not talking about the word exactly. We're more talking about the notion.
Right. What do we mean by science?
What is the idea that we're trying to box into a word?
Exactly.
So we don't really care about the word.
Right.
It's more just what's the notion that we're trying to get.
And what I'm saying, if it's broken, you got to fix it. Sorry.
So we never had a good criteria for this notion.
Right.
This is what you're saying.
And so we need to define what science is. And that's why you have to look at what the science tried to achieve. And I'm saying everybody that deals with science wants an explanation. We want to know how gravity works. We want to know how light does its magic. You know, all these experiments that people have seen out there, observations, whatever. They say, well, tell me how Mother Nature's doing that trick, that magical trick, right?
That's why the mathematical physicists also always go into how things work.
Yeah.
At the end of the dissertation, at some point they say, and that's how a magnet works.
Yeah, but then when you tell them, hey, but the explanation you gave me is irrational, they say, well, that's philosophy anyways. Or you're not supposed to take it literally. They give you answers on that.
The representation again. Oh, there we go again.
That's why we need to define the word science once and for all. And today, science is really religion. That's why we need to define the word science. People have this mistaken idea that science is about convincing people, persuading people, that's what science is about, saying, we proved it.
Yeah. Enough people believe it.
Right, and they'll raise their hands and vote.
That's one that's thrown in my face a lot. You know, whenever I bring it up with my friends, it's like,
is that why you get the black eyes?
So many people believe this, you're gonna think it's wrong. It's one of those things, like you're crazy. One of those things. You know, I don't bring it up a lot, but when it comes up, it's like that's not really a good argument.
It's a delicate point, right?
Yeah, it's like it's not really an argument. A million people believe this. Does that make it true? You know?
Yeah.
I mean, I guess the flat earthers also have that problem.
Yeah, it's like religion. You know, you have all these different religions. This guy believes in Mohammed, the other guy in Gautama, and so on. You know, and what are you going to say? Oh, I've got the truth. You got the lie. I'm sorry.
Well, yeah, but again, it comes up to a lot of points like cigarettes. For the longest time, people thought that cigarettes were healthy, but then the belief changed. Like, okay, we're starting to kind of see more facts.
The tar.
Yeah, once you start coughing your lungs out, you're like, maybe it's not that healthy, buddy.
Okay, Thal brings in the issue of observation. Okay, another issue that's very touchy in the word science. At first, it seems rational that facts and observation have no place in science at all, and that science is only rational explanations. But without observation, what is there to explain? Oh, very important question, because this word observation is a killer. People think that observation has something to do with science. So I'm going to give you 3 arguments. I have more arguments. I'm just going to give you 3 arguments of why the word observation should be eliminated from the lexicon of science completely. We don't need the word observation at all. Here's the first one, okay? Here's the first argument.
Depends on how you define it, though.
Well, I'm getting to part of that. Okay, here's the definition of what observation means. So this is argument number 1. This is the wrong context for observation. In the religion of mathematical physics, so-called science, the word observation is a synonym of proof. It's a weapon that is used against you. Observation means I have proven my theory and you have no say in the matter. You have to believe it because we proved it through an experiment. And here's the equation to verify our observation. The theory is now a fact. Deal with it. That's what observation means. Okay? So whenever you hear observation, they're trying to shove a fact down your throat. That's a theory down your throat turned into fact. That's what it is. Okay? You have the theory of evolution. Is that a fact? Well, you'll have a lot of these people say, well, it's a fact. No, it's not a fact. It's a theory. And they say, well, theory is like a belief. And so they don't like the word theory. They say, no, it's been proven.
Well, what is a
What do you
fact?
mean proven? Proven, you mean it turned into a fact?
What is a
fact? For whom? For you. Well, a fact means that it's a done deal. Like you can't contest it. You can't challenge it anymore because it's a fact. We've proven it. It's proof now. It's fact. It's a done deal. And it's like you can't challenge it because, evolution is a fact. No. Evolution is a theory. There's another theory that says God made Adam and Eve, right, with a magic wand and he put them on earth. And a lot of people believe in that theory. And this guy says, well, I don't like that theory. Yeah, well, yeah, but that's a fact for this guy and this is a fact for you.
Maybe the word fact needs better definition.
No, we need to get rid of the word fact, proof, observation. Because observation means fact, proof, means your theory turned into a done deal. That's what it means.
Well, usually when someone says fact, what I understand under the notion fact is what Mother Nature knows, essentially what God knows to be true, whatever that means. It's it's what none of us could really know for 100%.
She knows for a fact.
Yeah.
What happened. It's in her file cabinet.
It's kind of like in like problem solving math books where they have the answer on the back. God has that answer, but we never get that answer.
Right,
you can
only believe.
Yeah, you can only get close.
you can throw ideas out there and say, well, I think it's this. The other guy says, I think it's that. And that's fine. But to say, no, mine is a truth. Yours is not a truth. Mine is a fact. I turned my theory into a fact. Well, this guy has a different fact.
It's just too wishy-washy to talk about beliefs.
You can't talk about knowledge. You can't talk about proof. You can't talk about fact. In science, that all belongs to religion. Yeah. Why do we do experiments? To get evidence. Why do we present evidence? To persuade the jury. Religion.
Or ourselves even.
Yeah, or ourselves. Yeah, right. But I mean, what's the purpose of evidence? To persuade. That's what we use evidence for. That's why experiments and evidence have nothing to do with science. We don't do experiments in science. I know people say, what are you saying, Bill? How can you say that? Yeah, we don't do experiments. We explain them.
Well, because you
have to explain.
Because you could do logic with assumptions. You don't really need...
Yeah, I'm getting to that in a second, but let me give you an experiment. Here's an experiment, okay? There's an experiment. I can do it repeatable to make it very scientific. Here it goes again, okay? Okay, so what did I learn? That the pencil falls to the floor? Do I know why? Can I explain the cause that brought the pencil to the floor? Do I have particles pushing on it? Do we have strings pulling on it? By doing an experiment, I have not done science yet.
You didn't see the angel; it was grabbing it.
Yeah, I can say that too, and I can say that. I can say it was angels, and the guy says, "No, we've proven it was particles."
But none of these theories are a fact.
Yeah,
one of them is actually
mine is the one that's a fact.
That's not true. One of those theories is the fact, but we'll never know which one is the fact.
Mine is the one that's a fact always, for me. Yeah. No, you can't use knowledge, fact, or proof. Not in science.
I like fact because fact is like, again, the answer
that Mother Nature.
Yeah, that Mother Nature knows.
God knows.
We'll never know which one the fact is. We can just like
Mother Nature, God, the devil, all those people know, but we don't.
A lot of people know.
But they're up there. Yeah, we'll never see them. Maybe when you get to the pearly gates. Okay, here's argument number 2.
Are those going to be your first words in the pearly gates? Was I right?
See, I knew it was a fact. Okay, here's
now send me down. I can prove it to everyone else.
Okay, here's argument number 2. Stephen Hawking was a guru in black holes. Stephen Hawking never observed a black hole in his life. No one has to this day. Stephen Hawking what? Inferred that there was an unimaginable zero-D object that mediated unexplained cosmic phenomena. Stephen Hawking simulated stars twirling around and losing gas from the skins to this zero-D entity. Okay? Therefore, again, the word observe is used as a synonym of proof and fact. You cannot challenge the black hole hypothesis anymore today.
Someone already saw it, so it has to be real.
Yeah, you have to remember that the black hole has always been inferred indirectly, and they'll tell you that. They have no problem telling you that. They'll, all these people like Genzel, the other day he won the Nobel Prize. Well, one of those, the other one was, what was his name? Roger Penrose. They won the Nobel Prize for what? For inferring indirectly. That's what their papers say that. They inferred indirectly that there is some massive object that we can't see, that we can't touch, that is zero-dimensional, that has all this mass that's moving stars around.
But by definition, you can't see a black hole. So you have to infer it.
Even that's wrong, because then you have Stephen Hawking says that you have this light coming out of there, that black holes, suck, when it pulls a photon, the photon breaks into two virtual particles. One is the positron, the other one the electron. One is sucked in, the other one flies out. I don't know why it flies out, because all the gravity should be pulling it in.
That one's massless.
But yeah,
that's the answer to that one. No, but a good example is air, where no matter what tools you use to see air, you can never see it. You can always just see its effects.
Yeah. Again,
it's always inferred.
Yeah. It's a theory that says there are atoms here, and I'm breathing atoms, that there are these particles that are flying around, and it's a theory. And the guy might say, well, it's a fact. No, it's not a fact. It's a fact to you because, right, a proof that can't be challenged, and you say it's a fact. No, you can't say it's a fact. You're putting a theory saying, look, let's assume there are particles called oxygen or whatever, nitrogen, and they form this gas that we can't see, and I'm breathing it. And I pass my hand, I can touch it, I can breathe it, but I can't see it. And so that's your explanation. That's an explanation. Yeah, but it's an explanation. It's nothing but an explanation. As soon as you say it's a fact, well, it's a fact to you. Because the other guy says, no, these are spirits that we're breathing. And what are you going to say? No? And the other guy's going to say, no, it's energy, or who knows what. I mean, he can come up with anything. And that's what he believes. For him, it's not a fact that there are particles here. They say, well, that's an assumption. And he's right. It's just an assumption, and you're using that assumption to explain why you can breathe.
People don't like that. People don't like that wishy-washy beliefness to it.
Yeah, it destroys their argument.
No, but it doesn't sound right to say, I believe there's particles going in my nose. It's like, you feel it, you're like, what do you mean belief? I can feel it.
But the other guy says, no, it's spirits that's going into your nose. What are you going to say?
That guy's a dumbass.
Obviously, for him, it's a fact.
He's dumb.
I'm sure I go to the jungles, maybe some long-lost tribe out there that's still in the Stone Age, and you'll say, what is that stuff you breathe? The guy say, oh, that's the spirit of my grandfather. What are you going to say to the guy? You're going to say, no, look, there are these particles we call atoms. What are you going to explain to the guy? No, the guy believes in something else. For him, it's not a fact. And that's all there is. All you can do is have an explanation, a rational explanation, and some people subscribe to it, and some people don't, have some other explanations.
I really think people just don't like the word belief.
Yeah, because it means that, you just have a belief.
Yeah, it's not. You just pulled it out of your ass. That's what it sounds like.
No, in fact, they have that. In the case of, evolution, the religious folk come in and they say, well, but it's just a theory. And that just drives them up the walls. What do you mean it's just a theory? It's a fact. Evolution is a fact. It's just a theory. Like, say, it's just a belief.
Yeah, but what's wrong with that?
Because theory does not mean belief. Theory means explanation.
Yeah, that's different. But
once you define theory as an objective explanation, then you have no problem.
Yeah,
but as soon as you put in there and say, it's a fact, I turn my theory into a fact, then you run into trouble.
But again, I just don't understand the what do you call it, reservation of using the word belief. Like,
because
it's not enough.
It means it's just your philosophy.
Yeah, it's not enough. It's not enough to say I believe I'm alive. What's wrong with that? Why do you have to? I don't know. It's not enough.
Okay, and here's the last one. Last argument for that. Okay, if I can get this down here. Okay, and this is the Mafia Principle of science. Observation equals testimony equals witness. You can't introduce witnesses in science. What you do is you follow Al Capone there, and he said has the Mafia Principle. Kill the observer. Kill the witness. No witness should reach the stand.
You're saying logic can be done without observations. We do it all with assumptions. So observers just muddy the water. Is that the issue?
Well, let's put it this way. We have a blind man. Okay? Now, he has trouble using his eyes. What are we going to talk about with him about the moon? On the other hand, you tell the blind man, you say, okay, look, there is this moon that's going around the earth. Okay? And I don't know why. And maybe he can explain to you why that moon goes around the earth. He never saw it. He just reasoned in his dark world. He never saw the moon. And you just explain to him the observation, what you saw. He hasn't seen it. Like Stephen Hawking never saw a black hole. But he can reason it for you. He can theorize it for you and give you an objective explanation. So that's where science stops.
So you're saying in this case, he's taking your observations as assumptions. So, like, okay, let's assume there's a big thing up in the sky. Let's assume we're a big rock.
Yeah.
What could be the explanation, taking these assumptions, what could be the explanation for this phenomenon of one ball going around the other?
Right. And that's the issue. The
and
issue
he's felt strings before, so you'd be like, okay, it might be this, for example.
And we don't deal with observations. We deal with assumptions. The word is assumptions in science. In science, we have no observations. We kill the witness. We burn his eyes. We don't want to observe anything. Okay? Observe means you're going to introduce testimony, witnesses. You're going to introduce what you saw. And imagine these people say, well, we saw. They don't use the word saw. They use the word observed, which is very tricky because they say, we observed a photon zipping by. And you say, well, what do you mean you observed a photon? Why do they use the word observe? Because it gives you that hint that, hey, we did see it with our eyes. That's what a lot of people out there, especially common folk, that's what they understand. They say, oh, they observed the photon going by. I thought it was an assumption. No, these people are making an assumption that there is such a thing as a particle called a photon, which is not a particle, by the way, but they use the word observe, and people say, well, the scientists observed it in the lab. Well, who am I to question that? That's how they use it as proof. They use eyewitnesses. I'm giving you my testimony. You're going to doubt my testimony? I'm a scientist? That's what they're saying. That's why the word observe should be eliminated from science. We don't use the word observe. We use assumptions, and we do not need to observe anything to make a theory, to explain something objectively. That's all that science is in the end. Okay, another fellow puts something along these lines. Lots of questions along this line, scientists and science. Says, putting yourself in the shoes of a scientist, living at just the dawn of powerful microscopes, what would you say about looking into a glass and seeing these animals? Kind of like what Robert Hooke did with micrographia. He just looked at stuff through the microscope and found a lot of stuff. He even looked at tobacco plants and so on. Well, this is the answer I give you. I would say that you should not call him a scientist. It's premature. He will be a scientist when he can explain the mechanism underlying what he observed. Why did you call him a scientist? So far, all he did was just is just a lab boy. He's just a gopher doing data collection for his master. So far, all he did was gawk. He saw something. Is that science just because he observed something? You know, observation is not science. Science is explain something. Explain what happened. Explain a mechanism objectively so that I can understand it. Not so that I believe it, so that I understand it. And people have problems with that because they want to introduce their religion.
It sounds so simple the way you put it, but
it
goes off the rails when...
Well, because people are not used to explaining objectively. People simply want to tell their religion. They want to say, well, this is what I believe. I believe it because all the scientists believe in it, and they proved it in the lab. That's essentially the argument of everybody out there. And that's not science. That's known as religion. In science, we say, look, let us assume there's this, and this is my theory. This is my objective explanation for how this took place. For example, magnetism. For example, gravity, light, electricity, the workings of the atom. So you're trying to explain something objectively, not so the person believes, so that the person understands the mechanism. Then he can reach his own conclusion in his own dark basement. You don't have to influence him. He'll reach his own conclusion on his own, based on his upbringing and education. Okay, and so here's another. Stars on the galactic rim travel as fast or faster than those in the center. So far, that's what a description. So far, you haven't explained absolutely anything. Oh, you're saying,
What's
I
the
saw
context
something.
here?
Well, again, the context here is this science? Is this observation? Is observation science? The guy that says, I observed.
He just stated an observation.
Yeah, he says, this is what
that
we
science?
saw. Yeah, should we put a period there and say, okay, we did science. Let's all go home. Let's get our Nobels. No, so far all you have is a description.
There's no question. There's no explanation.
Right. So this is just a description.
If someone asks why do the
Right.
stars on the outside travel faster than the center,
Then it's
that'd be a
interesting.
scientific question, and the answer to that would be also science.
Yeah, because you would have to explain objectively how that magic trick is done.
Well, I guess that's implied that this is a phenomenon to be explained.
Yeah, but see, they stop there and they say, "Oh, I did science because I found out that the stars, on the rim go as fast or faster." And then, does this description qualify as science? Just there where we stopped. It doesn't. That's not science. What we have so far. It's like saying, "Oh, I saw the chair fall down." Well, is that science? Maybe the explanation is why or what caused the chair to fall down. That would be a more interesting question. What have you explained? What have you learned? Should we give you a Nobel Prize for your observation? Because that's what they do today. They give Nobels to mathematicians for what? For discovering phenomena and describing them with equations. That's what they think is science. And so this is where they give all these prizes because they say, oh, that's science. No, that's not science. It's describing something, saying, oh, I found this specific behavior in nature. Okay, you found it, and
Scientific question, I guess. It raises a question.
unless you explain something with it, you just like you say, I'm the first one in the first person in the world to see a rhinoceros. Should I give you a Nobel for that because you're the first one who saw a rhinoceros? Say, oh, I found this animal. It's so weird. It's got this horn. And is that science?
It's
Just
scientist.
saying, I found a rhinoceros. I discovered it. I'm the first one. Give me a Nobel. Is that science? No, science is explaining something, finding something, tripping, and falling and saying, oh, I tripped and fell. I observed. That's not science. And that's what all these people do. They describe, they discover some phenomenon, they explain it, supposedly with particles, which is not an explanation, partly because particles are not particles. And then they say, here's the description, a mathematical description, here's the equation. They say, okay, give them a Nobel. That's what science is today. And all he did was persuade his peers, who think exactly like him to begin with. Okay, this fellow is also in observation. He says, see doesn't mean just with your eyes. Aha. We have all kinds of machines that see what we can't with our limited vision. Okay, so here's my answer. Can these machines see the invisible, intangible mediators of light, gravity, and magnetism? There you have them on the bottom, okay? You have an atom, you have light, which is known as an electromagnetic wave, you have a magnetic field there. Can these machines see these invisible, intangible things? If these are things, is a field a thing? Can you see a field? Can a machine see a field? Or can it just
See the effects.
see the effects, like iron filings, okay? And so, if so, what have the machines draw? Have the machines draw these invisible, intangible mediators for us? I want the machine, not that you program it, but for the machine to do it all by itself, to see if it can infer or whatever. If it saw, doesn't you have to infer? It says, this is what I saw. Okay?
You just see the
Can a machine do that?
You just see the picture of light.
Well, a lot of these machines, like, you take like a photo multiplier, and I use these machines when I worked as an engineer at AMD. And what they do is they're already programmed, their algorithm inside it is already designed to detect any blip, any frequency, anything as a particle. So it just counts particles, and you're saying, well, obviously, it's counting particles, right? No, it's counting something that it doesn't understand. It just treats it as a particle because that's what's been programmed into the machine. And so they say, okay, now you have a higher intensity, that means you have more particles. Well, is that what really happened? Or is that what you programmed into the machine? I mean, it's garbage in, garbage out. Whatever you put in, that's what you're going to get out. But that's been programmed into the photomultiplier. Okay, and you have a lot of stuff like that out there. You have an ellipsometer, and it tells you the thickness of a layer, say, of oxide or whatever, a layer of film. And it's already programmed to go in there and convert light through this table known as a refractive index. And it just says, well, light went slower over here. Did it go slower? Or is that just an algorithm that you programmed into the ellipsometer so that, when it gets little c, 300,000 kilometers per second, which should be wrong anyways, because that's only in outer space, not here where you have air, and air travels slower. And now it goes through this film of glass, for example, right? And now it says, well, it's 1.45 times the speed of light. Oh, what do you mean? Divide, I'm sorry, the speed of light divided by 1.45, 1.5, whatever. So so they're saying, no, the speed of light here is 200,000 or less than 300,000 kilometers per second. Well, is that simply because we programmed into the ellipsometer, or is that what light really does? Does it slow down? And then if it slows down, why does it speed up later on again? Okay, so
we don't care about that part.
Yeah, you put energy into it and start speeding up after it leaves the glass. Yeah. So again, these are all ad hoc type of things that we program into the machines. Okay, a couple more issues here, also related to science and some geometry and so on. Okay, and here it says, in magnetic levitation of your body, you would feel it as weightlessness. And he says touch. Weightlessness, if anything, is the opposite of touch. It means you're not touching anything. What touched you? What came in physical contact with you? Please draw it. I want to know what touched you. If you're saying that weightlessness is touch, just draw whatever touched you.
What does he mean? What does he mean? Weightlessness is touch.
Well, he's saying that if you're floating out there like an astronaut in outer space, he says that's touch.
What do you mean that's touch? What's touch?
Yeah, that's what I mean. I'm saying it's the opposite of touch. I would say weightlessness, if anything, is the opposite of touch. But if you think something touched the astronaut, please draw it. I want to know what thing touched the astronaut out there. That's what you got to explain, okay, or justify before we can believe your theory here. We can see the shape of magnetism with demonstrations such as you showed using iron filings. Okay, this is what I showed the other day. Let me get it up here. Give me a second here. Okay, and here you can see what's happening. Okay,
that's the one I showed you.
Yeah. And here you see a magnet, and they make all the iron filings bounce on some kind of trampoline of some kind, and you can see there the shapes that are happening. Okay, that are being created by this invisible thing we call a magnetic field. But as you can see, the iron filings are picked up one at a time closer to the magnet. Okay, you can see one at a time, they're going in there. Something is moving in that region we call a magnetic field. You have to identify what is pulling on a single iron filing. What is pulling on one iron filing? That's what you got to identify.
You're saying pulling.
Yeah, I'm saying
Might
pulling.
be pushing.
Okay, you can do pulling. I don't care if you do push. Please draw what's pulling or pushing on each, not on the whole thing. I want one iron filing. I want you to show me what physical object is coming in contact with one iron filing.
What if it's invisible?
Well, yeah, it is invisible and tangible, but this fellow says that this shows what, see, here's his comment. He says, we can see the shape of magnetism with demonstrations such as this. No, don't tell me about the shape of magnetism. Tell me what pulls or pushes on one iron filing. That's the answer that we need, okay?
He can't show you because it's invisible, I guess is what he's saying.
Well, but I mean, he's got to show me what came in contact. What does he propose? What does he propose?
But it's an invisible thing.
Well, I don't care. It's a thing. Draw it. Make it visible.
You can't. Make it visible.
Yeah, make it visible for my eyes. I want to see what came in contact. Or are you going to do it with spirits? Are you going to say there's a spirit that's pushing or pulling on one iron filing?
Well, I guess the point is it's invisible, so you can't draw it. It's like drawing air.
No, you can draw air because you make an assumption. You say, this is what I propose air is. Now you draw it and you say, this is what I think
If it had color, this is what it would look like.
You're right. If it had visibility, this is what it would look like. That's what we need for you to do with whatever's pulling on one iron filing. Don't talk about a field. Don't talk to me about what pulls on the shape of the magnetic field. Tell me what's pulling on the shape of the thing that's pulling on one iron or pushing on one iron filing. That's the issue. That's what you got to draw. And again, what we saw is iron filings moving. We did not see the thing that moved each iron filing towards the magnet and formed patterns with many iron filings. Please draw the shape of the object that came in contact with one iron filing and moved it. Okay, remember that's what good old James Maxwell came up with, and so did, for that matter, Michael Faraday, who played around with magnets and electricity. These fellows reached the same conclusion. That was in the 19th century. Unfortunately, people forgot. But James Maxwell said it very clearly. There is matter in motion. That's what a field is. Matter in motion.
You can see it in that
something is moving in there.
Something's doing something one
right.
at a time. There's happening.
It's pulling or pushing. You want to do push, no problem. I say it's pull. But what it's doing is one iron filing at a time is coming closer to the magnet. You got to explain what came in contact with the iron filing. You cannot say nothing came in contact with the iron filing because I can't see or touch it. Now, then you're putting angels, you're putting spirits in that same space. You're saying Mother Nature does this with spirits. That's all you said. So you're a religious person because you're introducing spirits. You're saying there's nothing there.
You're saying, like air, you have to give whatever magnetism
right.
is shape so that we can see, oh, okay, so it's like a rope that's doing it, or I don't know, it's balls hitting
right.
each iron filing and throwing it to you or something.
How do you explain air to someone? I mean, if you want to try to explain more or less logically, like I said, maybe to a pygmy or whatever out there in the jungle, well, you would say, look, let's assume that this thing that's here is made out of atoms. These are the atoms, okay? They form these molecules, a bunch of balls, yeah, they're all in there. And we're saying that this is floating around for whatever reason, and this is what we're breathing. So you would explain a phenomenon in that way. Can we see the atoms?
Air.
No. You draw them and you say, this is what I think is in that invisible region. And that's the same thing we do with light. We say, what is light? Well, some people believe it's a series of particles. So what do? They draw a bunch of particles. Other people draw a wave, and they say, well, I think it's a magnetic and electric field. They go at 90 degrees, and they draw this, the famous field. Magnetic and electromagnetic field.
Visible.
Yeah, what are you doing? Well, you're turning something which is invisible, you're making it visible, so that you can give your explanation, someone can follow what you're saying. Do the same thing with gravity, do the same thing with magnetic field. Just tell me what physical object's in there, draw it. Don't tell me, draw it. Put a picture, an image, so we know what came in contact with one iron filing. Don't talk about the field and
we'll
say,
extrapolate to the rest.
That the field has shape. No, we know the field has shape because we see it in the iron filing. Tell me what came in contact, what shape, what thing came in contact with one iron filing. And then we'll know if you know. Okay. Then we can use about knowledge.
Yeah. The shape of
please predict.
Well, the shape of the amalgamation of all the things is a different question.
Yeah.
We just want to know one for now.
We want to know one. What came in one. Don't make it complicated. We'll make it easy for you. Just draw what came in contact with one iron filing, and we'll be done with that.
We'll extrapolate to the rest.
And here's what a field is. A field is a region of space. Well, this fellow, he did it the other day. Said a field is a region of space. He put the stuff up there. Yeah. And what is a field? Well, each point is associated with a quantity. So what is a field? A bunch of quantities, a bunch of numbers. And the static field at any given point in space is a number. And that's what good old Nick Lucid, good old Curly there, that's what he put. That's the reference he gave. And that's what good Nick Lucid put in his site. He put a bunch of numbers. He says that's what a field is. So you can't say that a bunch of numbers does anything. And this fellow continued and said, well, those represent atoms.
Represent.
Yeah, because he's got to represent it. And so that's what I'm saying. Here you have two magnets, okay, the little circles there, okay, and there. Okay, these are magnets, right? Okay, are you saying that in between here, there are atoms? Is that what pulled them together? Is that what the field represents? A bunch of atoms that are in here that are pulling these together, or maybe on the outside? What is bringing these two magnets together? Are you saying nothing is there because you can't see or touch it? Is that why it's nothing? Then you're putting spirits. You're doing black magic. That's all you're doing. And so you can't say the field did it because a field is a concept. Bunch of numbers. That's what this guy said is.
We kind of crap on the word represent a lot, but
Yeah.
aren't we using representation when we give color to the invisible objects?
We're making an assumption, not a representation. We're making an assumption. We're saying, let us assume.
Let us assume air is a bunch of balls.
Right.
That's not a representation.
Right, you're saying, let us assume. We're going to make an assumption. That's why you don't say, I believe, because that's religion. I've proven, that's religion. You just say, let us assume, so that you understand what I'm going to explain. Then you're okay. But as soon as you say, I've proven it, it's a fact, give me my noble, then we got religion. Okay? Okay, a couple more questions
You don't
here.
like these noble guys, do you? But
No, because they're all, it's just politics. It's a club. It's politics. Okay, so I put here, the entire language of so-called science is corrupt, has been distorted beyond recognition by all mentally retarded autists who run and have full control over the world of math. Okay, that's essentially. They use euphemisms, figures of speech, okay, and so on and so forth. That's essentially my conclusion. Particles are not particles. Spin does not mean spin. It's not spinning like a top. You know, I talked about that in the past. It's an orientation. It's weird. They don't even know. They don't have a definition for the word spin. But every time they use the word spin, they insinuate that it's what a top does. And that's not what spin is, because what does half spin mean? What does half spin mean? Well, what is this nonsense?
3/4
spin. They're giving you numbers to spin. I spin the top and, oh, that's a 3/4 spin. So yeah, they have all these euphemisms. Straight is not straight. When they say straight, they mean rectilinear, because they're talking about motion and not about something that is straight. Flat is not flat, and so on. They have euphemism. Infinity, we just talked about that. Infinite and infinity. There's no such monster in physics, in science. So you can't use these words. They use all these words because they come from mathematics. That's why they've introduced them into physics. You can't use these terms in physics.
They thought the words would help, but they didn't.
No, it just confused everybody worse, because people say, well, they observed. No, they didn't observe anything. You can't observe anything in the real world, in the invisible world. All you can do is make an assumption. But when they say observed, it's like, I saw the particle. I saw the virtual particle, for example, right? Okay, last two questions, and then we'll open up the floor.
We got like 2 or 3 questions.
Okay, so
Good ones.
Okay, so let's go with this. Gravity is in the same configuration as magnetism. That's what this fellow says. The shape of magnetism around the planet. Well, there you have it. Does a gravitational field look like a magnetic field? First of all, you have the magnetic field in the North Pole, at least. You know, you can see that they go in and they come out the South Pole. Maybe it's the other way around. Who cares? The point here is that pattern there, formed by the magnetic field of the Earth, does not match the gravitational field of the Earth, which is all towards the center. So you can't say it's the same configuration. Gravity is not magnetism. You got this from the electric universe. They believe in this stuff, that it's electricity or magnetism. These people are
There's
insane.
different shapes.
At the center of a planet is zero gravity, environment point, source 0 point. Yeah, and that's different than what you have for magnetism. We can see that we can see that it's acting the same way as magnetic attraction with a Cavendish experiment. Absolutely not. And there you say it. I don't need to go beyond this. Gravitational field is not the same thing as a magnetic field, and
The effects have different shapes.
they have different. This should be basic. This should be kindergarten stuff. But
And we just saw with the iron filings.
Some
They didn't-
people
they
just
didn't all
drown.
They didn't all go in. They kind of did this weird.
yeah, and
Shape.
that's not what gravity does.
does.
Gravity is
Gravity
always
is stupid.
directional. That's why they had to invent negative gravity. You know,
Right.
because you have
Doesn't that just push?
no. You got to understand this. What is dark energy? Dark energy is negative gravity. What you have is gravity should pull everything in. So we had this big explosion known as the Big Bang, right? 14 billion years ago. So everything's expanding. You say, well, why doesn't all that get pulled back by gravity? I mean, you have all this matter that should be pulling at each other. And so they said, that's because we have this negative gravity, and we're going to call it dark energy, which is pushing everything out against the gravitational pull of mass. That's what dark energy is, and that's what they're studying. These bean brains that call themselves mathematical physicists, that's what they do. They study dark energy, which is allegedly negative energy. If gravity is pushing out, and that's the positive gravity. The negative energy, the negative gravity means pulling in, and that's what dark energy is, the opposite of gravity. I said it in reverse. It should be.
Yeah. You lost me.
Yeah, okay.
Gravity pulls in. Gravity pulls
and
in.
we'll call that positive gravity. Negative gravity is pushing out, and they call that negative gravity. They call it dark energy. Yeah. That's what pushes everything out. That's what they invented, the opposite of gravity. Yeah, anti-gravity.
Anti-gravity.
Yeah, that's dark energy.
I've seen that in sci-fi. They have the anti-gravity.
No, it's not sci-fi. It's called science.
Oh my goodness. Science. Science nonfiction.
Last question, and then we'll open up the floor here.
Where do you get these questions? Like the ones that you're putting?
These are from last week. People who put comments. They put comments in the video.
Huh.
Okay, last one here. Objects. 3-dimensional is a requirement in physics. He says that an object has to be 3-dimensional. Okay. We don't know what definition he's got for 3-dimensional. I guess it's that one down below because that's the one he put. Okay. And again, the physics definition of object in Wikipedia originated from physics dictionaries. Absolutely not. What does the Wikipedia say? In common usage. It doesn't say the physicist said. No, it says in common usage. They don't have a definition for the word object in all of science, in all of physics. Why? Because they don't use objects in mathematical physics, and those are the people who are in charge of so-called physics.
They don't care about objects.
They don't care about objects, so there is no definition of the word object because they never realized that you can't do physics without objects, and they don't because they're going to be doing equations. They're not going to be doing moving objects around.
They do physics with the length of the object. They do physics with the location of the object, but they don't do anything with the object itself.
And that's one issue. The other one is that they don't give any importance to physical interpretations. They call that philosophy.
Probably get a little bit because they at some point they throw in their 2 cents.
No, but when you put them against the corner, you say, hold it, that's irrational. They say, we're not supposed to take it literally. Or they say, well, that's philosophy anyway. That's a belief.
This poor dumbass, he thinks I'm being literal. It's a representation, obviously.
And then again,
what's the non-representation of it?
Is that what an object is? A collection of matter? Here you have a collection of apples. Is that an object? A collection of apples?
Pile of apples. What's wrong with that?
Is that an object?
It could be.
Doesn't look like an object. It's a bunch of apples. And is light mediated by an object? We need an answer to that. Is there an invisible, intangible object in there that mediates light? And there you see a whole bunch of lights crisscrossing. Do the little photons ricochet? They bounce against each other and pop out? Like when you put two hoses, water hoses against each other, you'll see the drops hitting each other and bouncing out. Is that what you see with light?
Well, the photons are really small.
Yeah, and they have all this these weird explanations where they turn the photon into a particle-antiparticle pair that recombine again and turn into a virtual photon. That's how they explain all this nonsense.
Do they have to dodge the other particles?
Yeah, you should. Well, they do it
with. They're about to hit each other. They turn into non-particle. Let the go through, and then they turn back.
They do it with Feynman diagrams. It's all nonsense, all math. It's just saying, well, look, they split up. They turn into particle-antiparticle pair. Then they recombine, turn into a virtual photon again, and they continue. And then the detector detects that. And so they, through this rigmarole, they try to give you a physical or a semblance of a physical interpretation. And you say, well, what caused the photon to split up into positron and electron pair?
Now you're just asking extra questions. He answered
and they never explained that. It does. It did. And what is that? That's magic. That's just, magic wand.
Well, you got to use magic at some point, don't you?
Yeah, so do I. Here's my magic wand. Abracadabra.
But at some point during a theory, you have to say it just does, don't you?
Well, again, science should be assumption, explain the theory objectively so that a person understands we're done with science. What continues then is religion, belief, your opinion. You take it home, you believe in this one, the other guy believes in the other theory, okay? How did the window break? This guy said, well, a dog jumped through the window. The other guy said, no, it was a baseball bat. The other guy said, no, hit it with a crowbar. So you have all these different theories of how the window got broken. And all you do is explain it rationally or objectively and say, look, this is what I think happened here. And the other guy says, this is how I think it happened. And then everybody leaves the scene and everyone can believe in whatever they want to believe. That's religion. The objective explanation is the only part that concern science.
Do you want to get to questions?
Let's go to the questions. Go slowly. Sometimes you skip too much.
No, I don't skip any.
And people get upset and say, "Oh, you skipped my question."
Sometimes they ask the same thing like 7 times or something. It's like,
Okay.
I'll get them.
Okay, let's see.
Okay. Oh, this is talking about, this isn't so much a question, but it's a comment on knowledge.
Okay.
Usually you know things, saying if all things go as expected, there are always random things that happen, but it's not, that doesn't make you wrong. It just implies there are things you were not aware of.
Yeah, but again,
for example, the comet hitting Earth before the pen hits the ground.
But that's why we should not use the word knowledge or the word wrong, because wrong is an opinion. Wrong and right just means you qualified it. You suddenly gave it a qualification that was unwarranted, not in science. And what is knowledge? Knowledge means that, again, the way we define it is that you can predict something's going to happen, because that's how you prove your knowledge to the professors or whatever. You want to show something to someone, you run an experiment, you say, I can tell you what's going to happen if I do this experiment. Then you have knowledge, if you can predict it without error.
But you can't, because there's always things you're not aware
right,
of.
That you're not aware of. There's many things happening out there, variables that you cannot, factor in because you're not aware of them. Like, I'm saying, okay, look, I'm going to let go of this pencil, right? And I let go of it 10 times and say, look, it always falls to the floor. And suddenly I let go of it and it stands in the air. And you say, how did that happen? And it turns out that I tricked you. I fooled you. I had 2 magnets, pulling on the metal, inside it. And I just turned the magnets on, the electromagnets on, it stays in the air. And you didn't know. Okay, so you did not know that it was going to fall to the floor. You did not predict. We cannot know. Not even God can predict anything.
As a side note, these questions and comments might be more meaningful if I do them in the moment. I don't want to sidetrack us too much.
We can bring them up anyways. Okay, go ahead.
Saying for the next time, it might be better to do this real time.
Okay.
Do you understand that the basis of psychopaths is thinking love is a concept? Have you done the rice experiment, or do you just ridicule it?
I ridicule it.
What's the rice experiment?
I have no idea. But love is a concept. What is it, a physical object?
Google it real quick.
Is love a physical object? Are you saying that you can draw a picture of love? That it's got shape? That because that's what a physical object is, and there's only 2 types of words. One is concept, and the other group is objects. And so it's either an object or a concept. If you know of a third category, hey, you should bring it on.
In his latest experiment, Emoto prepared 3 jars of rice. He wrote, "I love you" on the first one, "You idiot" on the other one, and ignored the third one. After a month, the first jar of rice went sour, and there was mold on the rice in the second and third jar. So that's a no for you. Okay.
Nonsense.
So you're a psychopath.
Yeah, I'm a psychopath. No doubt about it.
Sidestep my question once again, Gady. What is there to explain without first an observation?
Yeah, you don't need observation. You make an assumption. Okay? You don't need to observe.
What's the
again,
difference?
Einstein did not observe space-time. Hawking did not observe black hole, and that means that they cannot give you a physical interpretation for how what's happening to these stars out there that move around. They're giving you a physical interpretation. I don't agree with them because they say there's a singularity full of mass.
But that's besides
but that's their assumption. They're saying, well, we can describe it mathematically, and that's our physical interpretation, that there is something out there. Did they observe? No, they observed the sun running, star going around in circles. They did not observe the black hole. That's an assumption. That's an inference. And the same with light. You see light do something. And are you going to say that there's nothing there? There's no physical object there? So you make an assumption. You say, well, let us assume that there's an electromagnetic wave. Or let's assume that light consists of a series of particles that travel in a rectilinear fashion. Then you make an assumption.
Oh yeah.
That doesn't mean that you either believe or that you need to observe. You did not observe light, the mediator of light.
But this question goes before that. They're saying, how are you even going to ask a question if you didn't even observe something?
And again, the problem with the word observe is that they treat it as proof first. No, that is important. It's important. Let me go through those steps here so that this fellow understands. First of all, it's used as the word proof. That's what observe means. So that's the first reason you got to remove the word observe. But you say, I need to observe. You can only observe what you can see. Visible. We're talking about the invisible. Did you observe the invisible? Did you observe the intangible? Did you observe the mediator of gravity? So can you say that if I let go of the pencil, okay, I can observe the pencil?
We're observing.
Did I observe gravity?
Yeah, but without even observing a phenomenon, how can you ask a question?
Again, that's not science. Science is not the observation part, and we don't use the word observe in the scientific method. We say, let us assume. Because you have to make an assumption for the mediator of gravity. You can't say, I observed gravity.
No, that's not the point. The point.
That is the point. Remember, that is the point.
The point is I guess is asking the question science. Because when someone says, oh, the moon goes around the sun, goes around the earth, for example. Well, that's an observation. How can you even ask the question if you didn't see the moon go around the sun?
Yeah, but the question here, it's very tricky because you did not observe the gravitational mechanism. And so people use the word observe and say, well, I observed. What did you observe? You observed the moon going around the earth, but what you're trying to explain is gravity. You're trying to explain the mechanism of gravity. You cannot say that you observed gravity. So you don't need the word observation at all. You just make an assumption.
You mean you don't need the word observation to explain something?
Right.
Or you don't even need observations.
Where in the scientific method do you find the word observation? In the rational scientific method. In religion, yes, what mathematical physicists do, they use the word observation because they're going to say that we observed the photon. Did they observe the photon?
I don't think that's the.
It is.
That's not what I said. Again, like for example, when we're talking about magnetism, the shape of magnetism.
Yeah.
We're seeing the shape of magnetism, not magnetism itself. We're seeing the effects of.
But
magnetism.
This is the issue. People get confused between the invisible stuff and the visible part.
Yeah, but just talking about the visible part. Here we see the shape of the iron filings, right? So we're seeing something.
I didn't observe anything, for example. Okay. I didn't observe anything. I want to talk about this hypothetical situation of a star on the other side of the universe. Did I observe anything? No, I make an assumption. Let us assume there's a star on the other side of the universe. Let us assume there's a moon, there's an asteroid, there's a comet. I can assume anything. I don't need to observe absolutely anything in science.
You're saying you could do science without any bearing on whatever.
I can make a hypothetical. I can make a hypothetical situation.
As long as it follows logically, A from B, then you're doing science.
I'm explaining the mechanism, not what I observed, not the observation, but I'm explaining a mechanism, what caused this thing to happen.
Going back to the blind guy, if someone explains, but gives you these assumptions, there's a rock going out around another rock. Then the guy doesn't have to see anything, but he's still going off your observation. But you're saying that observation is irrelevant. He could have just come up with this. Yeah. He could have invented a rock going around another rock, and the blind guy has to say, well, what could be the explanation?
Let me give you another example. ETs. They came in the past and they built the pyramids. Did we observe that? We observed how the Klingons came and built the pyramids? No. You see a pyramid.
But you see a pyramid.
You see a pyramid, but you did not observe the mechanism of how the pyramid was built. So you crash, you bump your nose against a pyramid. And now you have to explain, did you observe how the pyramid was built? And so you make an assumption. You say, let us assume there are extraterrestrials, the Klingons. They came here 2,000, 3,000, 4,000 years ago and they built the pyramids. So you make an assumption. But you did not see how they built it. You did not see, because an observation means you saw it over time and you saw how it was built. And you say, I observed it. No, you did not observe. You just saw a wall.
Okay, but going off of what you're saying, you could do science with imaginary stuff that has nothing to do with reality.
What if I talk about dragons? What if I talk about God? I mean, did I observe God make humans?
So you can do science with dragons.
All I need to do is understand what the guy's proposing. So the guy says, let us assume that God exists, that there is a God, a magician. The guy's got a magic wand.
We know what a magic wand looks like.
Okay. And he took a little bit of clay, he put it together, he blew and spit on it.
That's not what I heard. He didn't do all that.
And suddenly Adam and Eve came into being. Okay? Did anyone observe any of that? No, he's making a hypothetical assumption. He's saying, let us assume their God is there and he made man. We didn't see any of that. We did not observe. We just see humans. And you can say, well, I saw a human. Yeah, I mean, what does that have to do with anything? What does observation of a human? You bumped against a human, you bumped against the wall. You don't know how the wall was built. So no, observation has nothing at all to do with science. Observation is only a fancy way of introducing testimony. That's all it is.
We can see the shape of magnetism. I guess talking about the iron filings.
Yeah.
Isn't that your definition of object, that which has shape?
No, that's not the shape, because shape has to be static. And what you have there is something moving. What did James Maxwell say? He said it's matter in motion. What you have to do is stop the matter in motion, and we'll see if those iron filings, I mean, if you could do that, right? If you could stop the threads from spinning, which is my theory, there wouldn't be any magnetism, because you don't have the mechanism to pull on those iron filings. And so the question now is put to you. Please make visible, make observable the thing that came in contact with one iron filing. Then you'll have an object. Then we can follow your presentation. Otherwise, you're just doing it with spirits. You're doing it with black magic.
Isn't invisible, intangible, physical mechanism, double ropes, single thread, backed without observation experiment, invoking spirits' religious beliefs?
Yeah, we do it without observation, and it's got nothing to do with religious belief, because it's not a belief. It's an assumption. It's known as an assumption. You say, let us assume.
We're guessing.
Yeah, it's a guess. It's a proposal. Mm-hmm. You're saying, let us assume that the invisible stuff out there in the universe is mediated by a thread or by a rope or by whatever. That's an assumption. Just like quantum mechanics makes an assumption that, or classical mechanics makes an assumption that there are particles. And they say, let us assume there are particles out there, discrete particles. And that's how they base their explanations. And I'm doing the same thing. I'm saying, let us assume there's a thread, there's a rope. It's got nothing to do with belief. It's a proposal, it's an assumption. You know what assumption is?
What's the difference between hypothetical and theoretical? Is the EM rope theoretical or hypothetical?
Hypothesis in rational science, not in a religion of mathematical physics, not in a religion of what they call science today. In rational science, in true science, genuine science, hypothesis only includes the objects, the definitions, and the initial scene. Theory is the explanation of a mechanism. One has nothing, hypothesis has nothing at all to do with theory.
So is the EM rope theoretical or hypothetical?
The electromagnetic rope is a hypothesis, not a theory. There is no theory called rope. This is a rope, okay? This is a rope, and this is an object. And so we're not talking about a theory yet. We're just saying we're presenting the mediator for light and for gravity, which is this invisible, intangible thing that has shape, right? That's what a thing is. And with that, we're going to explain the mechanism.
I think the problem is in ordinary speech, they're used interchangeably. Theoretically, hypothetically.
Yeah.
Do you understand your big joke to the engineering / scientific / physics community?
Yeah, it's mutual. Half of the world laughs at the other half.
What is there to explain without first an observation? Yeah, I guess we went into that.
Yeah.
If humans and other creatures lose their genetic diversity eventually, how living things started with a lot of it? That's
I explained that with a graph the other day. If you look at my previous video, I covered that issue. You have that when, let me explain in a few words. I don't have the graph here to show you, but if you look at a new species, it branches off usually from some other animal, normally, okay? So it gets isolated in a different region of the planet. One example is the Neanderthals. What happens? They migrated, as far as I'm concerned, their forefathers, really, you go back all the way to man of Heidelberg, and even before then, Homo erectus. There was some kind of creature, two-legged creature, 800,000 years ago in England, okay? And if you go there, you'll find these evidences, these pieces of evidence. They found a footprint. They found some elephant bones. They say, who hunted these? Who burned these? Well, they say it's some kind of human that was there at least 800,000 years ago. And that had to be the range of Homo erectus, Homo heidelbergensis, who were the forefathers of Neanderthal. Okay, so Neanderthal came out of these folks. How did he come into being? Well, at some point, Neanderthal branched out. The main line, Heidelberg, died, and what you have now is man of Neanderthal. Now, when he comes out, he goes into a region which is totally different than what his forefathers had. And what happens now? This Neanderthal gets used to the cold. He had no clothes. And so he develops certain genes, or some of the genes pop up that have to live in the new environment, which is different than what man, who came out of Africa, assuming that's what happened, right? Who comes out of Africa in a milder climate, he doesn't have to fight against that, so other genes develop in his world. So these guys are different. Why? Because they had to cope with different environments. And what happens? You take that thousands of years into the future.
But they're both losing genetic diversity?
No. At first, they gain genetic diversity because we have this selection going on because of the climate, the animals they hunt maybe or are hunted by, they have to live in different environments. Because of that, they develop different, maybe one's closer to the sun in the sense that, not like if you're in a higher latitude, what do you have? You have maybe less ozone or whatever. There are different climatic conditions. My point here is the following. When a species gets isolated in an environment, all it can do at the beginning from the mother branch is gain genetic diversity.
So it goes up.
Yeah, it goes up because you're fighting against a new environment. And then once you settle down more or less, then it only can come down. And after that, you can't gain genetic diversity. You can only lose it until you have almost no genetic diversity left, which is the state of humanity today. We are all clones of each other from a genetic point of view.
So it's not
there's not that much difference.
So it's not that a species start off with a lot and it just kept going down. It's like these
it goes first. Genetic diversity increases, then it starts getting
once it
lower.
gets used to the environment,
and especially diseases. Diseases are the sifter of genes, because once you conquer a disease, that disease can no longer affect your species. And we are the products of thousands of years, first of founder's effect, followed by population bottlenecks. And that constant process is what made us today. That's why we're all the same. That's why Japanese is equal to you genetically, not because they married in with us, but because their grandfathers passed through the same diseases.
I guess a good example is like 10% of you survive a certain disease, extreme case. Everyone after that comes from those 10%.
Right, and so we don't have to marry a Japanese or a white man like me, an African, in order to enrich our genetic pool, because their grandfathers and the grandfathers of the Orientals and so on, they all went through the same diseases. That's the sifter.
We're all the same.
We're all the same because of that. We passed all through the same diseases. Except for COVID.
Oh, we're going through that one now. But that one's also global.
Yeah.
Also, would atoms look different on the edge of the universe than closer to the center, where there would be more EM ropes arriving to them from more directions?
Yeah, that's a big question that we've dealt with a lot. We've dealt with that in the past.
But we didn't have to observe the center of the universe.
We didn't observe it, okay? No observation. We didn't observe the end of the edge of the universe, but we can still try to explain what happens.
Would they look different?
Well, I think they would. We're still haven't finished debating that one completely. We're still trying to crack that egg.
I say they look like teardrops on the edge of like a hydrogen atom would look more like a teardrop at the edge of the universe, because all the ropes that makes it would be coming from one direction.
This is my explanation, okay? And again, it's not final. I just want you to get an idea of where I'm coming from with that. The atoms at the edge, completely at the edge of the universe. We're thinking about maybe there's a galaxy, the last star, the last planet, so to speak. Think of it in those terms, okay? And what happens is, what would you see at the edge of the Earth today? Well, you see the edge of the universe, because what happens at the edge of the earth is you have a magnetic field. So the edge of the universe is not filled with atoms. The edge of the universe is swept by magnetic fields, which are threads. A magnetic field is just a bunch of threads that are twirling around. That's what a magnetic field is. That's what those lines of force are. They're just threads, physical threads. Otherwise, you got to explain the lines of force. What are those lines of force? And they say, well, those are, you put them in there ad hoc to explain
representation.
Yeah,
no, something's pushing is more than a representation.
Something is pulling on this, and you're saying that's just a representation. Line of force, we know that because we throw iron filings, they line up, yeah?
Well, what's doing it?
But then what's forcing the iron filing to line up? What comes in contact with one iron filing? That's what you got to identify. If you can't identify that, you're not a scientist.
Next question. No, you're sidestepping again. Einstein saw the Earth and the Sun and explained with general relativity. Newton saw the apple and the Earth and explained. You need to assume about what you can already see.
Well, I talked about that the other day. Newton did not have an explanation. So no, Newton never had an explanation. He said, "Fingo non hypothesis," meaning I have no hypothesis, meaning in rational language, I have no theory. I have no explanation for how Mother Nature does this, especially when he was a particle man. He believed in particles. So he said, I cannot explain it with particles, how the Earth rolls around the sun, how the moon rolls around the Earth. He could not explain it. Einstein did not explain it. He gave us the most irrational thing he could come up with. He says, time is warped. That's what he said. Time is warped. That's the wall that comes up against the skin of the Earth and prevents the Earth from flying away. That's what he explained. Is that an explanation? Is that a rational explanation to say time is warped? At best, it's a description, not an explanation at all. But for sure, it's not an explanation, a rational explanation. That's the physical interpretation Einstein's going to give. So no, there is no explanation from Einstein or Newton that passes rationality.
You do not understand the question at all. You see the moon and the Earth. They go around each other. So in science, you put a rope or whatever invisible to explain. I guess he's saying we only explain things that we notice in real life. So the observation always comes first. The observation comes before the question, I guess is what he's saying.
You cannot explain invisible stuff.
No, but he's saying
you cannot observe.
I guess he's going even before that. He's saying we couldn't even have questions.
Yeah, we can. We can have questions. I can tell you what's happening at the edge of the universe. I've never been there, but I can imagine it and I can visualize it and I can give you an explanation.
But aren't you extrapolating from things you've already seen?
You can go as far as you want. I've seen the pyramid. I have not seen. Observation means over time. Observation doesn't mean that I bumped against the wall. I have to explain how the wall was made. That's what observation means. I have to put every frame in the film.
I guess to the extreme.
That's an observation. You can't say I observed the pyramid. You had to observe the pyramid to explain it. No. The issue here is you have to observe the construction of the pyramid, not observe the pyramid. That's called seeing, not observation. Observation is over time, many frames of the film. So you cannot say you observed the pyramid.
I guess to the extreme case, if we were all blind and had no senses, would we have any? Would we have any questions?
You can imagine,
but you can only imagine because you have senses, I guess is the point.
It doesn't matter because the issue here is I did not see God make Adam and Eve. I can still imagine it and I can still talk about it and I can still propose it. I didn't have to observe God. I didn't have to observe Adam and Eve being made. I can make a hypothetical situation. You're the guy who doesn't understand.
What is science's relevance to the natural world if science may as well be about totally imaginary objects?
It's not imaginary objects. You got the word imaginary. You're talking about imaginary. It's not There's no such thing as imaginary objects. There are objects and there are concepts. So which one is it? Is it an object? Does it have shape? Or does it not have shape, in which case it's a concept? So if I put a dragon has shape, it's an object. It's not an imaginary object. We don't say that's a red object and that's a big object. We don't use adjectives in front of the word object. That's where the problem is. An object is an object is an object. It's that which has shape. An angel is an object. It's not a concept. It's not an abstraction. An angel is known as an object. Why? Because it has wings and has a little plate on his head and he's holy. I can draw an angel for you. I can show you a picture of an angel. I can draw a heart. I cannot draw love. That's why love is a concept.
Do all our assumptions that we make come from past experiences?
I don't know, but I have no experience with the edge of the universe. Sorry. I don't know what the edge of the universe looks like. I can only visualize and make an assumption about the edge of the universe. Was I ever there? No.
No, but based on things you've seen before, I guess.
Well, you can take that as far as you want. Again,
That's what
you have
doing.
to. No, but they're wrong. They're wrong. We make an assumption. Assumption is not an observation. Observation is testimony. We don't use testimony in science. Don't confuse the word observation with assumption. Assumption is something different than observation.
Some people argue that humans can't really eat plants. Plants were eaten as slave foods.
What? Well, I don't know. Okay. I'll pass on that one. Some people, humans can't eat plants?
So now observation becomes important in irrational science? I don't know if that's a question.
Yeah, we don't use the word observation. Observation is religious people who want to introduce testimony. That's the way we see it. The word observation means proof. The guy is not talking about observation. He says we've proven. We've seen, we've observed the photon. That's what they're saying.
Taken to the extreme, you could say that robots, like a program, can do logic, even though it has no senses.
It has no senses. What do you mean?
When a program does logic, I'm saying logic can be devoid of senses. That's essentially what you're saying.
Yeah.
But again, a good way to show that is programs don't have any senses. It just takes in whatever we give it, and it does logic with it.
Yeah, and again,
and that's what you're saying.
Yeah, but
with rational science, you don't need. You're saying it's a coincidence, basically, that the assumptions that we make are based off of the things we've seen. Like, for example, when we see a pyramid, not how it was built, forget that, just the pyramid, and we want to explain how it was built.
Then you use the word see. But you see see.
Yeah. But you're saying it doesn't matter if we saw it or not. You could have assumed it.
Yeah, you can assume, you can make an assumption about a pyramid for you. Let's say you never saw a pyramid in your life. You never even imagined. And suddenly you visualize something. You say, what if there were a pyramid made of rocks?
Big. How could it have been made?
Yeah, you can come up with anything. I mean, you don't have to see it. You don't have to observe anything. You can just make an assumption. You can make an assumption, like I said, about God and about Adam and Eve. You never observed God, and it's a theory. You don't believe in that theory, fine. Other people believe in it. So again, it goes to what each person wants to believe. You might say, well, that's not science. Well, neither is space-time. What is scientific about space-time? What is scientific about a black hole? What is scientific about Big Bang? Those are all religions.
There's many non-observed phenomena that we talk about.
Yeah, what is a particle? A particle is a number. That's what a particle. There is no such thing as a particle in quantum mechanics, not a corpuscle. So what is that? Did you observe the particle? It's a collapse of the wave function. That's what a particle is.
Can you do a review response to Ted Kaczynski's manifesto? It's a hot topic on the internet these days.
Ted Kaczynski?
Yeah.
About technology, you mean? Yeah. I don't care about technology too much. Ted was a little wacko. He wanted to kill some people because he thought they were making too much progress. I have not much to say about good old Teddy. Any more than I have about, what was the other guy? The guy who used to rape women and kill them.
Marilyn Manson?
Huh? No. There was this fellow. He was put in the electric chair. I can't remember his name now.
There's a lot of them that did that. That one guy who raped and killed people. Oh yeah, that guy was a douche. Fuck that guy. That's it for questions.
Okay, we're done?
Yep.
Okay, folks.
You're free.
We'll see you next time. Anyways, continue to beat me up.
You didn't answer any question. You just sidestep shit. But all you do is play freaking hopscotch with questions. You never answered it.
Yeah, it's called politics, playing politics. Anyways, folks, we'll see you, what is it, on Sunday?
I'm always at the end of every month.
Yeah,
here to beat them up. I try to take people's questions and try to build them up.
Yeah, he plays devil's advocate against me.
I basically is just
and what I do when he does that, I don't feed him for a week. So he has
that's why I look so skinny.
Okay, we'll see you on Sunday, folks. Bye bye.